Hello dear students, welcome back to the video classes. Today we are going to study the relations. This is the second chapter, and in this chapter we are going to study what are the relations. This is the third lecture on the topic relation. Let me begin with what is relation, notation of a relation, domain, codomain, and range of the relation. Let me begin with the definition of a relation. A relation, denoted by the notation R, from a non-empty set capital A to a non-empty set capital B, is a subset of, means R is a subset of, the Cartesian product of A cross B. Here, A cross B is called the Cartesian product on the given two sets, and the relation is a subset of A cross B. The subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. A cross B is a set containing the ordered pairs, and in each ordered pair there is an element, first element and the second element. The second element is called the image of the first element. For example, the second element is called the image of the second element. For example, suppose A is a set containing the elements, some elements, then A cross B will be always equal to, it is a set containing the ordered pairs A comma B, such that A belongs to the first set and B belongs to the second set. Then relation is always a subset of the Cartesian product of the given two sets. The first element is belongs to the first set, second element is belongs to the second set. Here B is called the image of the first element. By using this definition, we are going to define the domain of the relation, codomain of the relation, and range of the relation. What do you mean by domain? The set of all first elements of the order pairs in a relation R from a set A to B is called the domain of the relation R, and it is denoted by D of R also. Similarly, codomain, the set of all second elements in the relation R from a set A to a set B is called range of the relation R. The whole set capital B is called codomain of the relation R. The range is always a subset of the codomain set. Dear student, here is an important note. The range is the subset of the codomain set. Now basically these are the domain of the relation, and range is always a subset of the codomain set of a given two sets. Here is an important remark. First one, a relation may be represented algebraically either by the roster method or by the set builder method. An arrow diagram is the usual representation of a relation. The total number of relations that can be defined from the set A to set B is the number of possible subsets of A cross B. It is given by the formula n of A cross B is always equal to n of A into n of B. N of A is P, n of B is Q, therefore n of A cross B is always equals to P into Q. And total number of relations is on A cross B is 2 raised to PQ. This is an important remark for CET exam point of view. With this, let me solve few examples. Now this is the first question which is solved from the textbook. Let A is a set containing the elements 1, 2, 3, 4, 5, 6. Define a relation capital R from A to E by R is given a set. It is a relation containing the order pair x comma y such that the second element is equal to first element plus 1. This is a relation given in the set builder form. We have to depict this relation using an arrow diagram, and also we have to write the domain and codomain and range of the relation capital R. To write all these things, let me write what is a given set is. A is a set containing the elements 1, 2, 3, 4, 5, 6. Let me obtain A cross A. Dear students, you know how to find the Cartesian product of two given sets. And that is already we have done in the previous class. Therefore, A cross A will be the order pairs containing 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Like that, the second element of the first set get ordered pair with the every element of the second set. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So on. The 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. This we have found A cross A. To obtain a relation R, one should have what is A cross A is. And relation R is always a subset of the Cartesian product on a given set. Now, the relation is R is equal to x comma y such that y is equal to x plus 1. If x is 1, then y is 2. If x is 2, y is 3. If x is 3, y is 4. And if x is 4, y is 5. And if x is 5, y is 6. Now this is the relation in. Now this relation we are going to represent by an arrow diagram. Now in this ordered pairs, the first element is belongs to the first set. Second element is belongs to the second set. Second element is the image of the first. Therefore, by an arrow diagram, we can represent the domain containing 1, 2, 3, 4, 5, 6. Second set is also in set A containing 1, 2, 3, 4, 5, 6. In this relation, we have the first order pair 1. The image of 1 is 2. The image of 2 is 3. The image of 3 is 4. The image of 4 is 5, and the image of 5 is 6. Therefore, this is the representation of a relation in by an arrow diagram. Now the second one is you have to write the domain of the relation. The domain of the relations are nothing but 1, 2, 3, 4, 5. 6 is not the domain of the relation. It is a domain of a given set, but it is not the domain of the relation. Likewise, we can write the codomain. The codomain elements are 1, 2, 3, 4, 5, 6. The elements of the second sets are called the codomain. But the range is the image of the first is 2, the image of the second one is 3, the image of the 3 is 4, the image of the 4 is 5, the image of the 5 is 6. Therefore, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. These are the members of the range R. Therefore, we have represented the given relation in the roster form, arrow diagram. We have written the domain, codomain, and range of the relation is. This type of questions will be expected in the examination for Let me begin with the problems from the exercise 2.2. Let A is equal to 1, 2, 3, 4, 5, so on to 14. Define a relation R from A to A by R is equal to, it is a set containing the order pairs x comma y. such that 3x minus y is equal to 0 or y is equal to 3x, where x and y belongs to the given set. Once again, we are going to write domain, codomain, and the range of the relation. To write this all domain, codomain, and range of the relation, we should find first what is A cross A. A cross A is a set containing the order pairs 1 1 1 2 1 3 1 4 so on up to 14 14. If x is 1, y is 3. If x is 2, y is 6. We have the expression like 3x minus y is equal to 0. Therefore 3x is equal to y. If x is 1, y is 3. If x is 2, y is 6. If x is 3, y is 9. If x is 4, y is 12. We can take the values of x up to 14, but its image which is not there in the given set. Therefore, the elements in the relation are 1, 3, 2, 4, 6, 3, 9, 4, 12, which is the roster form of the relation R. Now this relation R we are going to represent by an arrow diagram. But before that we can write domain of the relation. The domain of the relation is denoted by the notation D of R, containing the elements 1, 2, 3, 4. It is a set of first entries in the order pair. Ranges, the images 3, 6, 9, 12. It is a set of the second entries in the order pair. These are 3, 6, 9 and 12. These are the images, that is called the range. Codomain. Codomain in the given set is 1 to 14. And this is the representation of a relation by an arrow diagram. As I told you, these questions will be expected in the examination for 3 marks. Okay, students, let me take the one more example. Define a relation capital R on the set n of natural numbers by R is equal to, it is a set containing the order pair x comma y such that y is equal to x plus 5. Y is equal to x plus 5, where x is belongs to n and less than 4. Depict this relationship using roster for, write down the domain and range of the relation is. Now let me begin with the given set is a set of natural numbers. Now the relation R is given to you. It is a set containing the order pair x comma y such that y is equal to x plus 5, where x is belongs to n and less than 4. Now let me find the relation R in the roster form. If x is 1, 1 plus 5 is 6, y is 6. If x is 2, y is 7. And if x is 3, y is 8. If x is 4, I can't take the x is 4 because we have the condition there. X is less than 4 it is. Therefore, I cannot take the values of x 4, 5, 6 like that. Only the values of x will be up to 3. Therefore, the relation containing the order pairs like 1, 6, 2, 7, 3, 8, which is the roster form of the relation. In this case, the domain of the relation is 1, 2 and 3. The first element in each order pair of the given relation R is called the domain of the relation. And the image, second element of each order pair in the given relation is called the range of the relation. Now, we are going to represent this by an arrow diagram. If 1, 2, 3, 4, 5, so on, it is an infinite set. And n is another set which is an also infinite. The image of 1 is 6, the image of 2 is 7, the image of 3 is 8. Therefore 1, 2, 3 these are the domain of the relation, and 6, 7, 8 these are the range of the relation. As I told you, these questions will be expected in the examination for 3 marks. If you practice these questions, it will be easy to score in the examination. Dear students, I hope you have understood the today's lecture. If you have any queries, please contact the given below number. Thank you.